In this video, I will show you how to do the proportionality theorem proof. This is an examinable proof and it is usually for about 5 marks. So all you have to do is study the proof with understanding, memorize it, and replicate it in the exam. Now I've taken this question exactly as is from a past paper, so at the end of the video, I will show you exactly where each mark is allocated. It says in the diagram, triangle ABC is drawn. D is a point on AB and E is a point on AC such that DE is parallel to BC. Use the diagram to prove the theorem that states that AD over DB is equal to AE over EC. Now the first step towards proving this proportionality theorem is the construction. So the first construction is to join DC and BE. So in the bottom section of our triangle, we are going to fill in 2 diagonal lines. Now what you need to remember is that when it comes to your constructions, there are marks allocated to it. So you must mention your constructions as the first part of your proof. So we're going to write down construction. And also note that the construction is actually given as an instruction. So we're not going to say that we joined DC and BE, but rather we are going to say join DC and BE. The next step is for us to draw perpendicular heights. So from point E, we are going to draw a perpendicular height across to the line AD, and let's call this H. We're now going to draw another perpendicular height from point D across to AE, and let's call this perpendicular height K. So again, it is a construction, so we're going to write it here. We are going to call these altitudes, okay? So they are perpendicular heights. So let's say draw altitudes H and K. Draw altitudes H and K. Now the first step towards proving this, once we've done the construction, is for us to make use of area. So we use the area of these triangles to prove the proportionality theorem. Now, firstly, we are going to look at the left-hand side of the triangle. So we're focusing mainly on the left. And we're first going to focus on the triangle ADE over the triangle DBE. So putting special focus on the left-hand side, because the left-hand side will now represent the base of the triangle. So we're going to start off by saying the area of triangle ADE over, and in the denominator we are working with triangle DBE over the area of triangle DBE. Now we need to expand these areas. And in primary school, you learned a basic area formula for a triangle, which is half base times height. Also, in that formula, the height that we are concerned with is the perpendicular height. So, working with the triangle ADE, we are paying special attention to this side AD, because that is what we are going to take as the base. Where we have half base times height, we are now going to have half AD, and the height for this triangle, the perpendicular height, is H. So we're going to have half AD times H. The triangle in the denominator is triangle DBE, so Focusing on the left-hand side to get the base of this triangle is going to be DB. Now, in triangle DBE, we're going to have half base times height, so half DB, and we are going to take the height as the same h, which we've used for triangle ADE. So in the denominator, we're going to have a half times DB times h. So there we have a half base times height for both fractions. Now in our numerator and denominator, we notice that the halves are common, so they can cancel out. The h's cancel out as well. What we are left with is AD over DB. Now notice that this fraction matches the left-hand side of the answer that we're looking for. So we know that we're getting somewhere. Now, in order to get the right-hand side, which is AE over EC, we are now going to focus on the right-hand side of the triangles. So the first triangle we're going to look at, the triangle at the top, let's call this AED, and the triangle at the bottom is going to be ECD. So the next part of our answer is getting the area of those triangles. So we're going to say area of triangle, this is going to be AED over the area of triangle, and this is now going to be ECD. Now we need to expand these fractions according to the area of the triangle. We're also going to use half base times height, but focusing on the right-hand side of the triangle. So the first one, where we have triangle AED, the base of this triangle is going to be the right-hand side, which is AE, and the height is now going to be K. So it's the perpendicular height to that line. So when we expand, we are going to have a half AE times K. And for the triangle from the denominator, which is ECD, we are going to focus on the right-hand side as being the base. So the base is going to be EC, and the height is going to be the same K. So for that area, we are going to have a half EC times K. Now at this point, you'll notice that you've got a half in the numerator, a half in the denominator, K in the numerator, K in the denominator. They cancel out as well. In the numerator, we are left with AE. In the denominator, we are left with EC. So we've got the right-hand side of the answer that we need. We have AE over EC as they have it here. The next part is for us to equate these two fractions together, but at the same time, we need to mention why these two fractions would be equal in the first place. Let's pay careful attention to the numerators of these fractions. In the numerator, we've got triangle ADE, and in the second fractions numerator, we have triangle AED. What you need to notice about those two triangles is that they are in fact the exact same triangle. If we refer to our diagram, triangle ADE and triangle AED refers to the exact same triangle. So we understand that the numerators of these two fractions are equal to each other. But now let's pay attention to the denominators. In the first fraction, we've got triangle DBE. Let's focus on that triangle. So here we have DBE. And in the second fraction, we've got triangle ECD. So it's this, triangle ECD. Now we need to state why these two triangles will be equal to each other. And something important that you need to notice here is that this fraction has been divided proportionally, where we're going to look at these two fractions having the same base and also having the same height. And only if these two fractions have the same base and the same height, they would yield the same area. So that is a condition that must be met in order for those two denominators to be equal to each other. So that is what we are going to state. We're going to state that the area of triangle DBE will be equal to the area of triangle ECD if and only if these two conditions are met. And the two conditions must be that they have the same base and they have the same height. So another way of writing this is saying equal bases and equal heights. Now this tells us that in the denominators, so if we focus on the denominators of both fractions, if DB and EC are equal to each other, and if H and K are equal to each other, then those denominators will give us the same area for both triangle DBE and triangle ECD. That is when the denominators of both fractions will be equal. So once we've mentioned that, and we've said, okay, these two fractions are now going to be equal, we can now take the two fractions and equate them to each other. So we're going to say, therefore, the area of triangle ADE over the area of triangle DEB, or actually we wrote it as DBE, is equal to the area of triangle AED over the area of triangle ECD. So now we've shown that these two fractions are equal. And we know that the fraction on the left simplifies to AD over DB. So on the left-hand side, we can replace it with AD over DB. And we know that this fraction on the right-hand side simplifies to AE over EC. So on the right, we can replace that with AE over EC. And that is actually what the question wanted you to do. We have now proven that this triangle has been divided proportionally. So AD over DB is equal to AE over EC. That is your proportionality theorem proof. So let's look at where the marks are allocated for this proof. This proof was taken from a past paper where it was 5 marks, and the first mark is given for the construction. So construction plays a crucial role. Don't forget to write it down. There is 1 mark allocated. The second mark is allocated to this step where you have your first fraction and up until the point it's simplified. The third mark is given for the second fraction until it's simplified, so that entire step is important. The fourth mark is given for the step where you mention that the denominators are equal to each other and you give the reason why they are equal. So there's 1 mark for that whole step. And the final step is given for, the final mark, is given for the step where you equate the two fractions together. So that is your 5 marks. What I would suggest is you learn the proportionality theorem and try to test yourself on this theorem by using different labels on your diagram. They may not necessarily always give you the letters A, B, C, D, E. They can switch it up, and depending on whatever letters they have, you should be able to apply the exact same proof.